Hi guys, hello friends. Hope you're all doing fine. Now let us continue with this topic, relations. We have already started this topic. So shall we start, guys? Are you ready? Now what did we study about relations? First of all, it is a subset of, and first of all let us start with the notation of R. R or relation is a subset of A cross A. Hana, guys, do you remember? R is subset of A cross A. Now, how do we define a relation? That is, A is related to B if some condition is satisfied. This is how we define a relation. Now, before I go into the topic today, actually today's topic is types of relations. Before I go into the topic, I would like to introduce two terms. Domain. First one is domain. What is this domain? See, if it is subset of A cross A, then it is no problem. Okay. If it is A cross B, a relation from A into B. Okay, we are writing like A is related to B if something, some blah 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 we can write. But A element of A and B element of B. This is how we write. If this is how we write this relation. Okay, generally relations are like this form. I am just taking for a hypothetical example. That's not, you need not actually bother. But why I am telling you to introduce this topic of domain. This set, initial set on which we define the relation is called domain. And this final set is called codomain. Okay, it is called codomain. This is just for your information only. It is mainly applicable for us in the next coming topic. But anyway, I just said about the domain and codomain. Now, we will, in a relation, we have to relation class, the class, relative class of an element. Actually, if there is a set, let's say 1, 2 and 3, okay, and we are defining a relation. The relationship class of 1, if we have to define such a set, it is called the relationship class or relative class or relation class. You can tell any terminology for that. But generally the terminology is, it consists of all those elements which are related to 1. Okay, we have those elements which are related to this one. We can define any relation. But we are not going to that in deep now. What we have today is types of relation. First relation we define is null. I think from all you have learned so far in mathematics, you should be able to get the name null. Null means 5. Nothing, 0. If there is a relation, that is, if there is a relation which has no elements in it, then it is called a null relation. There can be many relations, right? That A element of R such that A is equal to root of minus 35. Can we find some element? It is an element of the set of real numbers. Since the negative number has no root in the set of real numbers, this is null. If B, that is, like if you are writing B, A, B. B is related to A if A element of n, that is the plus positive natural number, B element of R, and B is equal to root of minus A. Can we find any B like that? A is element of n, definitely A is positive, so definitely minus A is going to be negative. Therefore, there will be no element in this relation, and therefore it is a null relation. And there is another relation called universal relation, just the opposite of null. Just the opposite of null is the universal relation. In this universal relation, every element in the defined set is related. Every element in the set is related to every other element. Therefore, this is a universal relation. Set like let us say AB. Okay, such that A element of n, B element of n, and A B greater than 0. Yes, this is the relation. A and B should be greater than 0. Every element in the set of natural numbers is greater than 0, and therefore every element will be a member of this relation. There is nothing. This is a universal relation. These are only just examples, okay? You need to just understand the concept, because you won't get much related to universal relation and all in your exam. Now we are coming to the main topic from which you can expect a question for your board exam. That is, we define 3 properties. Reflexivity, first one. Reflexivity is if for any element A of A, the set we are taking, A element of R, that is A element of R, that is A is related to this itself. I am related to myself. Whether I am related to you or not, I am related to myself. Therefore, this is reflexivity. We will discuss this in one question. Okay, this is, I am just telling you the property. Symmetricity. What is this symmetricity? What is the symmetricity? That is, for any A, B. Okay, that is, let me tell you frankly, if A, B element of R, then B, A should be element of R. When we are taking from the reverse, should also be element, right? Like if 1, 2 is an element of R, then 2, 1 should also be an element of R, and both 1 or 2 are elements of the original set A. So this is symmetricity. Now we are coming to the final property, that is transitivity. What is transitivity? That is, if we are given A, B element of R, and we are also given B, C element of R, then A, C should be element of the relation. If A is related to B and B is related to C, then A should be related to C. Okay. This is A, B. If there are 3 friends, if A is this person, like this is one person, and he is his friend, and this person is in turn this person's friend, then this person should be this person's friend. It is not always true. We have to check. We have to check it whenever the relation is given. If there is a relation which satisfies all the property, then it is called equivalence relation. Okay, it is called equivalence relation. And by the way, the relationship class also has the name equivalence class. Okay, I told you about relationship class, right? It also has the name equivalence class. Now we are coming to the question. Let us say there is a relationship of let us say AB. We are taking AB element, or we can take any AB element of R if 2 divides A plus B, and A and B are element of natural numbers. Here we are not going to check like what writing each and every element till thousands or 10,000. We are just going to do in a systematic procedural way. First, we will check reflexivity. To check A. What is A plus A? We are taking A plus A. A plus A, we can write it as 2A. It is divisible by 2. Therefore, it is reflexive. Symmetric. If A be element of R, then let us say that A plus B is equal to 2K. Why? Because 2 divides A plus B. So A plus B is going to be a multiple of 2. And we are writing it as 2K. What is B plus A? You know addition is commutative, right? So B plus A will also be element equal to 2K. Therefore, BA element of R. Now, how we can write here itself is equal to B plus A. Therefore, BA element of R. No. A related to B, B related to C. Then, A plus B, let us say, is equal to 2K. And B plus C is equal to, let us say, 2L. 2K and 2L. Now, 2K and 2L. We are going to look like, what to tell? We are going to see if A means, how does this come? A plus B is divisible by 2 and B plus C is also divisible by 2 because B and C are related. Now we will see if A plus C is divisible by 2. Only then we can say it is transitive. How do we check? We are adding both. Now A plus B plus B plus C is equal to 2K plus 2L. Hana? Guys, do you get it? A plus B, we are adding these two equations, nothing. Okay, we are just adding these two equations. What do we get? A plus C plus 2B is equal to 2 into K plus L. What do? We take this B to that side. A plus C is equal to 2K plus 2L minus 2B. We are taking the 2 common, is equal to 2 into K plus L minus B. It is divisible by 2 and therefore A and C are also related. And by all these three, we are getting that the given equation, given relation is an equivalent relation. This sort of questions you can expect in your board exams. So we studied what of the basic terms of domain, and we studied the null set, the universal set. You means null relation, universal relation, and we also studied equivalence relation and how to check if a given relation is equivalent. So this is all with this lecture. We will again meet to continue our discussion in the next lecture. So till then, have a great time. Thank you.